Hey everybody, it's Tim back again for RF systems. And so to begin, let's go with how RF plays overall into the Lunasat. So as you can see in our functional block diagram, we have RF here. Let's start with the use case of a temperature sensor. So first we have our power system with our PMIC and our solar panels, as you know from module 3. And so that will be powering our whole system with 3.3 volts. And now, so from there, now that our temperature sensor is powered, it will be sending its data to the microcontroller over I2C. And then our microcontroller will create a packet and send that to RF, which will then modulate our signal and send out our message. So you might be wondering, how are all 500 Lunasats going to be talking with each other and to our lander? Well, first we have our data request query. And so the base station will make this request query and say, calling for Lunasat 1. Lunasat 1 will say, hey, that's me. Then we have our data transmit and processing. So then our Lunasat will say, hey, my temperature is 15 degrees Fahrenheit. The base station will say, man, that's a little low. What do you have, Lunasat 4? Lunasat 4 will respond and say, I have 45 degrees Fahrenheit. And so that means that there is a local heat sink at Lunasat 1. And that's really what our whole system will be doing. But instead of 4 Lunasats, it will have 500. Next, we have our antenna. And the Lunasat is using a PCB antenna, which is single-ended RF input and output, meaning that it transmits and receives. And this antenna is tuned for 915 megahertz, as that is what our transceiver is communicating at. And pop quiz, if we have to transmit a wave having a 700 megahertz frequency, should the antenna be shorter or longer, and why? Next, we have our transceiver or our radio. The Lunasats will be using Semtex SX1272 as the transceiver integrated circuit. And this IC takes in digital messages coming from the microcontroller and then modulates it to the communication protocol of our choosing. And this can be located at the bottom of the Lunasat board along with the rest of the circuitry, as demonstrated 2 modules earlier. Next, we have frequency modulation, which is really just the heart of all wireless communication. Now, frequency modulation is when a modulator takes the frequency of a wave and changes it by encoding a message onto it. And as you probably know, computers talk in binary or a series of ones and zeros. And on the right here, you can see 10111010, which in human language is the letter C. And so our transceiver has a local oscillator on it, or a clock, and this will be creating a sinusoidally varying voltage, or the carrier wave, as you can see below the encoded message from before. And what our transceiver will be doing is it will be combining the two. It will be combining the carrier and the encoded message to create our modulated signal, zeros having a longer wavelength and ones having a shorter wavelength, as you can see in the final result. And this modulated signal will be propagated to our power amplifier, and from there it will be sent out from our antenna. And just give a little summary of everything that's happened so far. Waves are characterized by their frequency and length. Radio waves are electromagnetic waves, and they travel at the speed of light in free space. And the antenna and transceiver chip are integral to having RF communication. Thank you, and enjoy the activities.